I hope you guys have all been enjoying your 2 days off. The test will be tomorrow, and what I'm going to do on this video is go over some problems on worksheet 9 and basically give you guys the review if that we were in class. So please take the time to watch this video and prepare for your test that will be tomorrow. Okay. So remember, when writing equations of lines, there's 3 forms that we have. There's point-slope form, which is y minus y1 equals m times x minus x1. And then there's also slope-intercept form, which is y equals mx plus b. And then we also have standard form, which is ax plus by equals c. Now remember, with standard form, we have 2 little rules that go along with it. The first one, a must be positive. And the second one is a, b, c must be integers. Okay. Alright, so let's go ahead and let's take a look at number 3. We're going to have to go through all 3 forms. Remember that the form that you always want to start in is point-slope form. Okay. And in order to do point-slope form, you need a point in the slope, which we have both in number 3. Okay. So we have y minus y1 equals m times x minus x1. Now remember, with point-slope form, you need to simplify double negatives. So our answer is going to be y plus 2 equals negative 4/3 x minus 3. Okay. Then to go to slope-intercept form, we need to distribute the slope through. So now I have y plus 2 equals negative 4/3 x plus 4. So y equals negative 4/3 x plus 2. Okay. And then to go to standard form, we need to have x and y on the same side, so I'm going to add negative 4/3 to both sides. So I have 4/3 x plus y equals 2. Remember that a, b, and c must be integers, and a is not an integer, so I'm going to multiply the entire equation by 3, basically multiply by the denominator to cancel it out, and we get 4x plus 3y equals 6. Make sure that you are multiplying all parts by that value. Okay. Alright, so for number 4, I'm not going to go through the whole problem, but remember that in number 4, parallel slopes are the same and perpendicular slopes are opposite reciprocals. So if your equation is already in slope-intercept form that was given to you, which it is, then you can just go ahead and find the slope of the new line. So if it's perpendicular, then the slope of the new line is going to have and then the second point is going to be at 1, 4, and also an open circle. Okay, slope is 1/1, and you're graphing the space in between. For the third piece, we need to test one endpoint. So 1 plus 1 is 2. So our ordered pair is 1, 2. Our slope is positive 1. And we are graphing this to the right. So we go up to 1, 2, closed circle. Slope is a positive 1. Okay. And there's your third piece. Now remember that piecewise functions are functions, so they need to pass the vertical line test. So if any point your pieces are overlapping, then you know you made a mistake somewhere. Okay. This is not considered an overlap because one's an open circle and one's a closed circle, so that means only that one point exists. The domain is -infinity to infinity. There's no breaks in the domain. For the range, it's a little bit tougher to see, but if we zoom in on this, notice that there is a break between 1 and 2. Okay? There's no values between 1 and 2. So our range is going to be from negative infinity to 1, close bracket, union symbol, 2, okay. And then the range will be from negative infinity to 1, union symbol, 2 to positive infinity. Okay. Alright, let's move on to other types of functions. Let's move on to absolute value. Remember that the standard form for absolute value is f of x equals a, absolute value x minus h plus k, where hk is the vertex, a is quote-unquote the slope, and the axis symmetry is x equals h. So for number 10, the vertex is 4, 3. The axis of symmetry is going to be x equals 4. The domain for absolute value is always negative infinity to infinity. And the range is going to start at the y value of the vertex. And if a is positive, it goes to positive infinity. If a is negative, it comes up from negative infinity. So basically, if your graph opens up, it's going to start at the k value, or the y value of the vertex, and go to positive infinity. If your graph opens down, the range is going to come up from negative infinity and then stop at k. So our vertex is 4, 3. So 4, 3. Our a value is 1 and 1. 1 over 1. And there's your absolute value function. Okay. The shifts, so the shifts are going to be right 4 and up 3. There's no vertical stretch or shrink, and it's not reflected over the x-axis. Okay. Alright, let's move down to number 13. So the vertex is going to be 6, 2. The axis symmetry is x equals 2. The domain is negative to infinity. And then the range, since a is negative, it's going to come up from negative infinity and then stop at the y value of the vertex, or in other words, the k value. So in this example, 2. Okay. So let's plot our vertex at 6, 2. We're going to go down 3 to the right and left 1, and then down 3 to the left and right 1. Remember that you graph these similar to slope, it's just that now you need to make a V. So we have quite a few shifts here. We have right 6, up 2, vertical stretch, and then reflected over x-axis. So remember that the difference between vertical stretch and a shrink, if the absolute value of a is greater than 1, it's going to be a stretch. If the absolute value of a is between 0 and 1, it's going to be a shrink. Okay. Alright, that's going to conclude our review on absolute value. Okay. Let's go ahead and talk about graphing linear inequalities. And let's take a look at, let's go with number 16. Okay. So for 16, we have y is less than 5. So that's going to be a horizontal line, and it's going to be a dashed line since it's less than. Okay. And that's going to go down since it's less than. And then we have y is greater than -6. So once again, a horizontal line because y equals creates a horizontal line. And since it's greater than, it needs to go up. Okay. If we take a look at the third inequality, we don't have it in slope-intercept form, so that's what we have to do first. So y is greater than or equal to -2x minus 1. So I start at -1, I go down 2 and to the right 1, or up 2 and to the left 1. Okay. And since this is greater than or equal to, we're going to go ahead and use a solid line. Okay. And then test the point 0, 0 in the original inequality. So 0 is greater than or equal to -1 is a true statement. So you want to shade to include the point. So we're going to shade to the right of the line. And then for the last one, we have the y-intercept at 3, and the slope is a +1. This is going to be another solid line. Okay. Test the point 0, 0. That is true. So we need to shade to include the point. So the shaded region will be along here. Remember, if it's true, you shade to include it. If it's false, you shade away from it. Also remember that when you divide by a negative or multiply by negative, you have to flip the inequality symbol. Okay. Alright, that concludes the review on linear inequalities. So let's go ahead and go down to start talking about quadratics. Okay. Remember that we have a couple forms for quadratic. The first one is considered vertex form. Okay. Vertex form, it's named that because it gives you the vertex. So the vertex is going to be 7, 3. The axis of symmetry is x equals 7. And then x equals 7. And since the a value is 4, you're going to have a minimum at 3. Okay. Alright, let's go ahead and take a look at 20. 20 is in standard form, so we have to do opposite b over 2a. So x equals -6 over 2a. So the x value is -3. Then we have to plug that in. Make sure that you use parentheses when you're substituting, because when you square a negative, it becomes a positive. So 9 minus 18 minus 4 is a -13. So the vertex is -3, -13. The axis symmetry is x equals -3. And then it's going to be a minimum at -13. Okay. Alright, let's go ahead and practice graphing quadratics. Okay. Let's take a look at number 23. So for 23, we first need to find the vertex. So x equals opposite b over 2a, which is 2, and plug that in. So you get 4 minus 8 plus 4, which is 0. So the vertex is 2, 0. Okay. The a value is 1, so it's going to be 1 over 1 and 3 over 1. And it makes a U shape, and there's your quadratic. The domain for quadratics is always -infinity to infinity. And then the range is very similar to absolute value. If a is positive, which means it's opening up, it starts at the k value, or the y value of the vertex, and goes to positive infinity. So we're going to start at 0 and go to positive infinity. Okay. And the shifts There's just right 2. There weren't any other shifts on our parabola. Okay. All right, let's go down to number 25. This is a square root function. Okay. And for the square root function, you first have to find the starting point, which in this case is -4, -1. So -4, -1. And then the a value is 2. Now remember that for square root functions, we always go right 1, 3, 5. Okay. The a value tells us how much to go in between each one of those points. So we're going to go up 2 to the right 1, up 2 to the right 3, up 2 to the right 5. Remember that square root functions can only go in one direction. The domain and range start at the starting point, so this is going to go -4 to positive infinity, and this is going to go -1 to positive infinity. If, hypothetically speaking, say our graph went down, then the domain would have been the same, but then this would have gone -infinity to -1. Okay. Alright, and then the shifts were left 4, down 1, and a vertical stretch. Okay. Alright, let's go ahead and take a look at number 27. 27 is an example of a cube root function. Remember that the domain and range for both of these is always -infinity to infinity. Okay. Find your starting point, which is going to be 3, 1. 3, 1. And then since your a value is negative, remember that the value between the first 3 points that you created, there has to be what looks similar to a line, and if it's a negative a, then it's going to be a negative slope, and if it's a positive a, it's going to look like a positive line between the first 3 points. Okay, if you remember for cube root functions, we always go right and left 1, 7. A value tells us to go how much up or down between each set of points. So we're going to go up 2 to the left 1 and down 2 to the right 1. Sorry, I went 1 too many. And then we're also going to go down 2 to the right 7 and up 2 to the left 7. Okay. So then the shifts are right 3, up 1, okay, vertical stretch, and reflected over the x-axis because your a value was negative. Alright, we're going to go ahead and go to the last page to talk about rational functions. This was before break. There's a lot of information with rational functions. To find the VA, you set the denominator equal to 0. So we have x minus 2 equal to 0 and x plus 4 equal to 0. So we're going to have VAs at 2 and -4. Okay. The HA and the SA is where it gets complicated. Remember that if the degree in the denominator is larger than the degree of the numerator, then you're going to have an HA at y equals 0. Okay, so let's go ahead and just take a little active note about this. So if the degree in the numerator, so a degree of denominator is larger than degree of numerator, you have an HA at y equals 0. So in this example, our degree in our numerator is 0 and the degree in the denominator is 2, so we are going to have an HA at y equals 0. To find the x-intercept, you set the numerator equal to 0 We only have a 2. We do not have a variable to solve for, so there is no x-intercept, which would make sense because you have an asymptote at y equals 0, so that means no values can cross this x-axis. Then for the y-intercept, you plug in 0 for all the x values. So we get 2 over negative 8, which is negative 1/4, and make sure that you write your y-intercepts as points. And if we had an x-intercept, the same would be true. Okay. All right, so let's go over to the graph. Okay. Now it's kind of hard to draw lines on here, but you guys will be able to follow along. Okay. So we have asymptotes at y equals 0. Okay. And then we have VAs at 2. Remember your asymptotes to be dashed lines. And negative 4. Now remember that you will be able to use your graphing calculator tomorrow. So what you're going to do is you're going to plug this into your graphing calculator and then go under the table values and list table values. Whatever points that you put on your graph, you need to list in your table values. Okay, but you don't need to plug in individual values, just use your graphing calculator for that. Now when you guys are done doing that, your graph should look something along these lines, but you guys can look up the values. Okay, if you forgot how to use your calculator, please make sure you review those notes and ask questions if you have them come in early before school. Alright, let's go ahead and take a look at 34. Okay. For 34, to find the VA, you set the denominator equal to 0, so you have a VA at negative 2. This time, the degree of the numerator is equal to the degree of the denominator. So when that happens, you take the ratio of leading coefficients. So the leading coefficient is 2, and the denominator is 1. So you have an HA at y equals 2. Okay. For the y-intercept, the x-intercept, let's do that one first. For the x-intercept, you set the numerator equal to 0, and you write it as an ordered pair. For the y-intercept, you take 0 and plug it in each x value, you get 0. Now, a little active side note here. When the x or the y-intercept is 0, 0, then it should follow that the other one is also 0, 0. If it's not, you made a mistake somewhere. Alright, let's go over to our graph. Okay. So we have a VA at negative 2 and a HA at y equals 2. Okay. Once again, you will use the table to fill in values from your calculator. We do know that the x and y-intercept should be at 0, 0. And when you're done with this, after you plug in values, your graph should look something along those lines. Okay. Domain and range. Make sure we go over those real quick. Domain, so you just can't have a value at the asymptote. So the domain is negative infinity to negative 2, union symbol, negative 2 to positive infinity. Make sure that they're open brackets because you have asymptotes. And then the range, same concept, negative infinity to 2, and then 2 to positive infinity. Okay. Alright. Alright, and then for the last example for rational functions, this one's going to be a little bit different. Okay, we still find the VA the same way, it's x equals 1, but this time the degree of the numerator is larger than the degree of the denominator, and it follows that if it's exactly one more, then you're going to have a slant asymptote. Okay? So this degree is 2, this degree is 1. So you're going to have a slant asymptote, and how you find that is by using synthetic division. So 1, when we set the denominator, x minus 1 equal to 0, so your root is 1. And then you write down the coefficients. Make sure you fill in zeros for missing values. Okay. So we have 1, 1, 1, 1, 1. And we drop the remainder. So we have y equals x plus 1 for our slant asymptote. Okay. Then for the x-intercept, it's going to be 0, 0. Y-intercept, 0, 0. Domain is going to be negative infinity to 1. And then 1 to positive infinity. Okay. Alright, let's go over to the graph. So we have a VA at x equals 1. And then we have a slant asymptote, which is going to be a slanted line, or in other words, a line with a slope of more than 0, or less than 0, just not 0. Okay. And then we know we have a point at 0, 0. And once again, you have to go to your graphing calculator and provide values tomorrow in the table. Okay. Alright, this concludes my review of this worksheet. Please go over this, email me with any questions that you guys have, and come in early tomorrow morning if you guys have questions. Okay? Good luck studying, and I will see you all tomorrow.